problems, which ones? $31. Okay, assuming that's in the textbook. Okay. So for 31, because it's an absolute value, you have to rewrite the problem as a piecewise function. So I knew that the vertex of the piecewise function was 3. So I said the positive version of the piecewise function if x is greater than 3, and by x I mean t, if t is greater than 3. I already scanned it, it doesn't matter, I'm not changing it now. The negative version if it's less than 3. So that's what I've got first, and then I went ahead and cleaned it up. So distribute my negative. 3 minus t plus 3. Minus minus makes a plus, so 3 plus t minus 3. And so I got negative t plus 6, and then just plain old t. We good so far? Okay. And then from there, I was looking for my derivatives. So I have -1 and +1. So there are no critical values because my derivative is not equaling 0. Does that make sense? No critical values? Huh? X equals 3 because that is where that's an endpoint. Because you're switching from one piece to another piece. So it's an endpoint. And then the -1 and the 5 because those are the endpoints of the intervals. And so I use the -1 and the 5 for that reason. So the 3 had to have been an endpoint. Or the 3 wasn't an endpoint. The 3 would have been, because we're switched, the 3 is not an endpoint. The 3 is actually, because you're switching from a derivative of -1 to +1, the 3 is actually probably a sharp corner. Let's go ahead and graph this and just see what it looks like real quick. Sorry, I had to think about it for a second. We could check and see if it's continuous. Is it continuous? Yeah, if you plug in 3, that's 0. It is continuous. So this is probably a sharp corner. Derivative is not 0. Three minus absolute value x minus 3. Yeah, has a maximum there. So what I did is I used the endpoints and then I used 3. Used 3 not because the derivative equaled 0, but because it switched right there from negative to positive. So this wasn't one where we could take the derivative as an equation and set it equal to 0, but because we knew at 3 something funky was happening, at the value of 3 we had an undefined derivative. We had the left hand and the right hand did not agree with each other, which means that at 3 the derivative did not exist, which means it is a critical value. Does that make sense? Because our critical points are where either the derivative equals 0 or the derivative does not exist. And at 3 we found, based on this answer, that the derivative did not exist because the left hand limit, right? And we're not talking limit as a y coordinate, we're talking as the limit as a slope. So the left-hand slope and the right-hand slope did not agree with each other. The left-hand slope was a -1, the right-hand slope was a +1. Those two things did not agree with each other, therefore there's a critical point at 3. So when we did extreme value theorem, we checked either endpoint, so the left endpoint and the right endpoint, and then we checked the 3 because there was a critical point there, which we knew because it was an undefined derivative there. Does that make sense? Okay. Whew, My brain was not warmed up properly for Math 2 to answer a calculus question. Now my brain is more warmed up. I'm ready to go. All right, is there another question you want me to talk about? 43? Okay. So this one, the original function did not need to be rewritten, so the work that I did here is I went straight into finding my derivative and setting it equal to 0. So the work that I'm doing here is I'm trying to find my critical point. So I took my derivative, I'm doing the product rule. When I did the product rule, I saw that there was an e to the x that I could factor out. Now, whenever you find e to the x and you factor it out, e to the x, when you set it equal to 0, it never gives you anything, because e to the x can, like when you set it equal to 0 and solve it, it doesn't give you an answer that's meaningful. So that gives us nothing. Then I had cos x plus sine x equals 0. And when you do that, you can just think about basically you need to have an x coordinate and a y coordinate that are opposite signs of each other. And so that happens on the interval from 0 to pi. So this is not the whole unit circle, this is just the top half. This is just quadrants 1 and 2, which is why we only got one answer for x, not 2. Okay, so that's why there's only one, and that happens at 3 pi fourths. So where the x, and it's because cos and sine, where cos and sine are opposite signs of each other, so they cancel each other out. So same number. So if you can picture this, 3 pi fourths is where you have root 2 over 2, and you have a positive and a negative. So if you can picture it, no, we're using the angle because it's of x. But if you can picture it on the unit circle, it is negative root 2 over 2, comma, root 2 over 2. And so that's why 3 pi fourths is the solution there, because these would cancel each other out. So that's how they solved the equation and said cos x plus sine x equals 0. Because if you can picture the unit circle, cos x plus sine x, those would zero each other out.
What would you put those for the
3 pi fourths.
the left part, like for f of something, or for the...
For 3 pi fourths is what you're plugging in for x. Yep. So as far as using the extreme value theorem, we're using the endpoint, so we're using the 0 and the pi. And then as far as using a critical value, the critical value that we found, which was what makes that derivative equal 0, the value that made the derivative equal 0 was 3 pi fourths. So we were using 0, 3 pi fourths, and pi. And here if we do the function e to the x times sine of x, 0 and pi, if you picture the unit circle, 0 is over here, pi is over here. Well, this is the point 1, 0. This is the point negative 1, 0. And so sine of both of those is just 0. So the output for both of those just zeroes out the whole answer. So both of those are meaningless for us. They do nothing. So that's why the output was 0 and 0. Because sine of 0 is 0, sine of pi is 0. So the outputs for both of those don't give us anything. The other one is a little bit more interesting because we know sine of 3 pi fourths is root 2 over 2. And then we have e to the 3 pi fourths. So we have root 2 over 2 times e to the 3 pi fourths, which is messy, but it's an actual answer. So we have a tie for absolute minimum because they're 0. And then for absolute maximum, we have messy answer. If it was calculator active, you could figure out what the number is, but this would probably be calculator inactive because it's unit circle friendly. All of those numbers were unit circle friendly, which tells you calculator inactive. Yeah. Yeah, Michaela. Okay, which one? 39. Yep.
I could find all the x's, but then I didn't know how to find the y. The y value?
Yeah. Plugging them in. Oh, it's calculator active. Because you're evaluating it at numbers that are not on the unit circle, that's why it's calculator active. Yeah. Well, this one you could know, but not that one. So if it's tan inverse of pi fourths, you would think about, it's tan inverse of 1. You'd think about so tan inverse tells you to look at quadrants 1 or 4. Tan inverse of 1 tells you what y divided by x are the same. And it would have to be root 2 over root 2, which is pi fourths. Yeah. All right. What was the question? You put both. So min is 0 for the y-coordinate at both locations, 0 and pi. So 2 locations for the minimum. Yeah. What questions did you guys have on there? Which one? Number 9. Okay. All right, so it says which has to be false. So it says, so you have a decreasing function. So if a function is decreasing, that means it's going down. So if it's going down, then f of 10 has to be the absolute minimum, right? Decreasing function, it's going down. Then your last point is going to be your absolute minimum. That's what decreasing would mean. Does that make sense how f of 10 would have to be the lowest? Okay. If it's a decreasing function, overall it's going down, then f of 4 is neither the highest point nor the lowest point. Or, well, that says relative. This I wrote is true, probably true. This is f of 4, probably we can't, oh, hold on, let me read more information. It's continuous, decreasing function, critical point at 4, 2. So it says if it's a critical point at 4, 2, that means that it has either an undefined slope or a 0 slope. So it is neither a relative maximum nor a relative minimum. Oh, that has to be true if it was decreasing the whole time, if it's a decreasing function. Does that make sense? Because for it to be a maximum or a minimum, it has to go up and then come down, it has to go down and then come up. So you're only going to have a maximum or a minimum if the graph is switching from increasing to decreasing or switching from decreasing to increasing. So for this to have an undefined or a 0 slope, it means what had to have happened for it to be decreasing the whole time is it would have had to do something like go down, 0 out, keep going down for it to be a decreasing function the whole time. Does that make sense? So we can have that 0 slope in there, but for it to be decreasing the whole time, it can't have been a maximum or a minimum. Does that make sense? So that's why I wrote true next to that one. F prime of 4 does not exist. That's possible. It could be a critical point and not exist, because it could have been undefined. So I said maybe. F prime of 4 equals 0. Again, maybe. It could be a critical point and be 0. We're not sure which one it was. We know it was a critical point, but we don't know which case this is. So they said critical point, so C and D I said maybe. F prime of 4 is less than 0. F prime of 4 is negative. That's an absolute no, because they said it was a critical point, and the definition of a critical point is that the derivative is either undefined or 0. That's what the word critical point means. And so as soon as I read that, I was like, oh, E is the answer that's wrong, because that negates the definition of critical point. Yes. Yes. All right, so it says, what is the range of the function? So what I did is I wanted to see if I was looking for the range, I knew that the extreme value theorem would be helpful because it could help me figure out what my absolute min is and my absolute max. If I know my absolute min and my absolute max, then I know what my range is. Does that make sense? So using the extreme value theorem, I need to know what my critical points are, and I already have my endpoints, okay? So what I did is I took this and I found my derivative so I could find my critical points. Does that make sense? Okay, so I did low d high minus high d low divided by low squared. I'm just doing the derivative quotient rule to find my critical points. And I ended up getting, I had a quotient as my derivative, and I set the top equal to 0 to figure out where my derivative was 0, and I set the bottom equal to 0 to figure out where my derivative was undefined. Okay, so the top equaled 0 at e, so the e was my critical point where the derivative equaled 0, and then x equaled 0 where my derivative was undefined, but if you take the function and evaluate it at 0, you get ln of 0. And is it possible to do ln of 0? No, it's not possible. So when I figured out the location where my derivative was undefined, that was actually an extraneous solution, and it turns out I can't use it after all. Does that make sense? Okay, so I did not use this answer at all. So now I said, okay, my interval is 1 and e squared, so I'm for sure using that to look for my absolute max and my absolute min. And then I had a critical point at x equals e, and so I'm also going to use that for my absolute max and my absolute min. Okay, and so from there, I'm taking my values for my endpoints and my critical points, and I'm plugging them into the function to see what my outputs are. And based on those outputs, I'm going to know what my very highest y value is and my very lowest y value is. And that very highest y value and very lowest y value is going to give the range of the function. Do you see how I'm kind of using outside of the box thinking to find my range? Very lowest y value is my absolute minimum. That's the bottom of my range. Very highest is my absolute maximum. That's the upper value of my range. So I plugged in 1. I got ln 1 over 1. ln 1 over 1 is 0. Because ln 1 is 0. I got plugged in e, I got ln e over e. ln of e is just 1, so I got 1 over e. And then I plugged in e squared over e squared, which is ln of e squared is 2 over e squared. So this is 1 over e is like 1/3. Does that make sense? Okay. 2 over e squared is approximately 2, e squared is like 9/2. 2/9 is like 0.222222222. 1/3 is like 0.3333333333. And so that means that 1/3 is my max. And 0 is my min. Does that make sense? So without a calculator, I figured out what my numbers were. So I knew that my range was, my lower end was f of 1, my upper end was f of e. And so my answer was A. Ln, it was ln of e squared divided by e squared, and then ln of e squared, the ln and the e cancel out, and so it gives me 2 over e squared. And then in my head, when I was thinking about evaluating this in my head, because I couldn't use a calculator, instead of doing e squared, I was thinking 2.71, which is approximately 3. And then you go, whoa, that's crazy. Yeah. All right, t to the 2/3 gives the distance of a moving particle from its starting point as a function of time t. For what value of t is the instantaneous velocity equal to the average velocity. Have you guys noticed they've asked this type of question over and over and over again on different questions? Okay. It's actually, did you recognize last night, that's actually the mean value theorem? Did anybody recognize that? Mean value theorem? So you finally learned it. You finally figured out like why they cared, why they've asked you this question over and over. So average velocity is slope. Average velocity is slope. And it's taking, average velocity is just taking the position equation and doing the slope with it. So what we do is we take the interval 0, so we plug in 0. If you plug in 0, you get an output of 0, so 0, 0, and then you plug in the other end 8. 8 to the 2/3 is you do the cube root of 8, which is 2, and then 2 to the second power, which is 4. So we get 0, 0, and 8, 4. There's our 2 points. And then we just find the slope from those. That's what average is. Average is just slope. So we do our y2 minus y1 divided by x2 minus x1. So 4 minus 0 over 8 minus 0 is 1/2. Okay, so the average rate of change is 1/2. And then it says compare that with the instantaneous velocity, that's just derivative. So then over here I did the derivative. 2/3 times t to the negative 1/3. So I took my instantaneous rate of change, my derivative, and I set it equal to 1/2. Does that make sense? And so what I did here is I just took this and I took the 3 cube root t and I multiplied it over here. And I took the 1/2 and I divided that over here. To see what I did there? Oh, the 4 is what 2 divided by 1/2 is. How many half cups go into 2? 4 of them. Yeah. That was me simplifying. Yeah. Yep. And then I divided by the 3. And then I did to the 3rd power and got 64 over 27. Yep. So you guys have actually been doing the mean value theorem for a while now because it's been showing up in problems without calling it the mean value theorem. Because the mean value theorem just says whatever the average rate of change is, there is one instant where the instantaneous rate of change is the same as the average. That's what the mean value theorem says. So we've been doing it for a while, we just didn't call it the mean value theorem. Yeah. Okay. Any other questions I can answer for you? Yeah. Two divided by 1/2, I flipped it up. I did like keep it, change it, flip it. And 2 times 2 is 4. I set it equal to the average. So here's the derivative. It's just the cleaned up version of the derivative. And I did the instantaneous rate of change, and I set it equal to the average rate of change. Because they said where, they said what for what value of t is the instantaneous equal to the average. So I took the derivative and I set it equal to the average value. Okay, so for number 10, they gave us the graph of f, and we just have to compare it. Well, because of answer C, this problem is a little bit advanced for you guys. We'll see if we can do it. I'll talk through it as much as I can. Okay, so f of negative 3. F of negative 3 is a negative number. But only slightly negative. Do you guys see that? F of 2 is, so it's like, this is like negative 1/2 maybe. F of 2 is positive 1. So we're saying what's false, right? Okay. Would you agree that f of negative 3 right here plus f of positive 2 right there, that answer is bigger than 0. That's true. Okay, so that answer is not false. Okay. F of negative 1 is right here, so that's a positive that's a little bit less than 1, right? F prime of negative 1 is a negative slope, and that negative slope, how negative is that negative slope? Is that like negative 1, negative 2, negative 1/2? What do you guys think? So this is kind of like positive 0.75. That's kind of like negative 1/2. Would you guys agree? Okay. So that answer is probably positive. I don't feel great about that one, but I'm going to say it's probably true. It's not definitely false. It's probably true. Okay.
Why is the F prime written like that?
It's a typo. They just didn't bring it down. Okay, so F prime of negative 1 we said is definitely negative. We think it's like negative 1/2, right? Double prime, so it's the derivative of the derivative. How can I explain this? We really almost can't even do this question. Ignore C for now. We're going to come back to it. All right, F of 1, F prime of 1. Okay, F prime of 1 is the slope right here. That is certainly negative. Would we agree with that? Okay. And then, or F of 1. F of 1 is a negative. F prime of 1 is a negative. You guys see that? So F of 1 is a negative. F prime of 1 is a negative. And they're saying a negative times a negative is less than 0. Is that true? No, which is why this is definitely the answer. Okay. We don't have enough information in our brains really at this point in time to do answer C, but answer C is clearly not the answer. So for E, F of 0 is a positive number, right? You can see the Y value is positive. F prime of 0 is the slope. That's also positive. Positive times positive is greater than 0. It's a positive. So we can see that this is also true. So we don't have enough information in our brains to do C, but we can definitely tell that D is wrong. We have enough information to see that negative times negative is definitely not a negative answer. So, all right. Are we feeling better about yesterday's assignment now? Okay. All right, let's go ahead and get those in a pile on our desks. I need to go get, or does somebody want to go get today's assignment off the copy machine? Marvelous. Okay, we have a book page, and then we have a support page that looks like this. That's not written on yet. Marvelous.